Welcome to the third week of the course Energy Demand in Buildings. Last week you learned about estimating energy flows in watt and making an energy balance in watt-hour. Before going further, let's make sure you know about confusing terms like energy or power, load and capacity, watts and joules. The easiest is to make an analogy between energy and water volumes, with which everyone is familiar. The right part of the table is about water, the left one about energy. What's come from a tap or a garden hose is a flow rate, a certain quantity of water per second. With this flow rate, you can fill a bucket with a certain amount of water. If you want 600 liter, 0.6 cubic meter, and the flow rate is 0.02 cubic meter per second, then you need 30 seconds to fill the bucket up to this 0.6 cubic meter. By the way, that is a rather big bucket. That is exactly the same with energy. An energy amount is the quantity of energy you get by multiplying the flow rate by a duration. Energy amounts are expressed in joule and an energy flow in joule per second, of course. These are SI units. But it is sometimes more easy to use units derived from these joules and joules per second. So, very often we will use watt instead of joule per second for energy flow rates. And that is very easy because 1 joule per second equals 1 watt. When it comes to energy amounts, it may seem a bit more complex. In our field, we have a preference to use watt-hour. 1 joule equals 1 watt-second. And to get it in watt-hour, you need then to divide by 3600. The easiest way to remember that is to remember that 1 watt-hour equals 3600 joule. So, as for us or any engineer or policymaker in the field of energy, we don't mind so much if you use joule per second or watt for flow rates or joule or watt-hour for energy amounts, because it is very easy to go from the one to the other. Having said this, in this course, we use systematically watt and watt-hour because it makes the calculation of amounts from flow rates particularly easy. You just need to multiply the flow rate by 1 to get the energy amount obtained during 1 hour. Unfortunately, we also have to deal with synonyms. Instead of talking about energy flow rates, you will find in many readers, books or literature the words power, load or capacity as equivalents. We are also using all of them in this course as is done in practice. Be aware that the term power may be confusing, as in electrical engineering it is also used as synonym for electricity. In this course we always use it as a synonym for energy flow rate, just like the words load and capacity. When we talk about energy demand or energy use, it is always about energy amounts in watt-hour, therefore. Right on the slide you see a summary of the different ways of expressing energy amounts. What you find on your energy bill, if you got any, is an energy amount in watt-hour, not a power. To make sure you master the principle, let's take the example of transmission flows. Imagine you have calculated the transmission heat flow of a wall using the equation Q is U times A times temperature difference between outdoor and indoor, with indoor temperature 20 degrees C and outdoor temperature 5 degrees C. The results of this transmission load calculation is minus 250 watt. Imagine both indoor and outdoor temperature are constant during 300 minutes. How much energy is lost by transmission in these 300 minutes? Well, that is load times duration in hour. 300 minutes is 5 hours. So the energy is minus 250 times 5 equals minus 1250 watt-hour. Let's take now the example of a television with a power of 76 watt. You can see this wattage on the label on the back of your television. How much would it use if it is on for 4 hours? Well, power times time is 76 times 4 equals 304 watt-hour. And a final example, which amount of energy will appear on your yearly energy bill if you use the television 4 hours a day, 365 days a year. And if we assume this is your only electrical appliance, of course. Power is 76, duration is 4 hours, time 365, so the total is 110,960 watt-hour, which is the same as 111 kilowatt-hour. If you like, you can also convert these watt-hours into joules by multiplying the watt-hours by 3600, which gives 399,456,000 joules, which is the same as 399.5 megajoule. This brings me to the last part of this lecture, which is about prefixes. Prefixes make it easy to express large numbers. At the level of buildings, we will be using very often kilo, mega, and giga. Giga. Well, you know now everything about energy amounts and energy flow rates, their different names and units, and most important, you know that energy in watt-hour is equal to power in watt times duration in hours. Thank you for your attention.